This is Mr. Anderson for Kellogg Community College with the second part to our Section 2 of Chapter 6, where we add and subtract rational functions. Now, one thing about these rational functions is that we're going to get into some very tricky uncommon denominators, but through a little bit of help here and a little bit of some examples here, you'll get to see how things are done. Now, if we look at problem number 8, that's on this worksheet, you'll notice that the denominators are almost the same. Now, check this out. You'll notice that this is a negative x. Now, what I can do with that is I can pull out a negative 1, which is going to make that a positive x. So now I have common denominators. So take a look. I've got 8 over x minus a negative 1, which I can pull out and put in the numerator or the denominator, and 7 over x. So what this does, it kind of turns it positive. So what I have here is 8 plus 7, or 15 over x. And it would also go to show you that the LCD here is x, and we cannot have x equal to 0 in this case. So there's our answer here. So in review, to pull a negative out of here, you just have to turn the symbol right there. That would turn that positive. And so you have 8 plus 7, 15. Now here's another negative right there, but let's distribute that right now. Let's make that a plus and make this a negative and make this a plus. So now it's good to go. But now we should probably try to focus on what the least common denominator is. Now you might say multiply the left side by 3x plus 15 and the right side by 5x plus 25 over each other, but there's a simpler way to do this. Notice that there's you can factor this out so it becomes x plus 5, and you can factor a 3 out here, which would make this x plus 5. So our common denominator both have x plus 5s in them, and this is 3 and 5. So our least common denominator is technically 15, x plus 5. So what I do is multiply the left side here by 3 over 3. And what that will do is it'll make this bottom number a 15, and multiply this side by 5 plus 5 over 5, which will make that a 15 as well. So this is 3x plus 9, because I'm distributing the 3 to the x and the 3. And I distribute the 5 here to the 1 and the negative x. So this is going to be minus 5x plus 5 all over 15, now that we've multiplied and got our denominator to be 15, x plus 5. And let's go figure out our numerator. Our numerator. Okay, so what we're going to do is take a look at our 3x minus 5x, which makes negative 2x, and our 9 and 9 and 5, which is going to make positive 14. Now I can kind of see that if I factor out a negative 2, I'm going to get x minus 7. That's not going to simplify with anything downstairs or in the denominator, so I'm pretty much done. Now, finding our excluded values here, you'll notice that if I set my 5x plus 25 equal to 0, to find my excluded value, move that over. So I get 5x is equal to negative 25, divide both sides by 5, x is equal to negative 5. So that's one of my excluded values. Now watch what happens as I do the next one. If I do the next one, I'm going to take my 3x plus 15, set that not equal to 0, move the 15 over, 3x is not equal to negative 15, and divide both sides by 3, x is not equal to negative 5. And one of the reasons why I didn't talk about my excluded value at the beginning is this might have given you a little window into the idea of what the least common denominator could be, since they both have an this kind of common factor inside here when we look at finding our excluded values. All right, let's go to problem 10. Okay, so what we're going to do here is, oh man, this is so close to being common denominators. The reason why it's close is because you'll notice that the second one is out of order. It would be really nice if x squared minus 16 would be our common denominator. And we can do that by pulling out a negative 1. And by pulling out a negative 1, then we can get this to be x squared minus 16. And that would then make this a plus instead of a minus. And now what I can do is just put the top together. So x and x make 2x, and minus 7 minus 1 is negative 8, and then this gives me x squared minus 16. Now, what's interesting about this is if I factor a 2 out of the numerator, this gives me x minus 4. And from knowing how this is a binomial in the denominator, this is going to be x plus 4, x minus 4, by the way, which sets up our excluded values, which is negative 4 and positive 4. Now look at our answer here. We're going to do our crisscross simplification. So 2 over x plus 4 is our problem. Okay, now let's continue working on with number 11. You'll notice that, again, these are in the wrong order, so if we just pull out a negative 1, and once we pull out a negative 1 with the subtraction, that'll turn positive. This is x cubed and minus y cubed. So, in short, we're removing a negative 1 and then the minus sign turn positive. So now we can put our problem together with our least common denominator of x cubed minus y cubed. And then we'll put this together. The numerator is, x and, 2x and x is 3x. And then the minus 3y goes right here. And this is over x cubed minus y cubed. Now what's important about this is that we can simplify out of the numerator a 3. So we get x minus y. And since this denominator is a cubic, we have to know our SOPs. So we're going to have our x minus y, because that's the cubic root of x cubed and y cubed. Then following the SOPs properties, the square of the first, so x squared, opposite property, plus xy. And then we square the y, which is our y squared. And you see we do have some simplification here and here. So our answer is going to be 3 over x squared plus xy plus y squared. There we go. And since this is an x and a y problem, I'm not going to talk about finding the exclusions on the domain. Okay, 2 more to go. Let's take a look here. Now what I have is let's see here, 2 minus 3x. And what I'm going to do here is actually I'm noticing that I have an x minus y and an x squared minus y squared. My least common denominator would be great to get x squared minus y squared. But how would I do that? Well, I would do that by multiplying the left-hand side by something that'll get me a difference of squares here. So that will be multiplying the top and bottom by the same, which is x plus y. And so let's do our FOIL here between this and this. And now we have a common denominator, and we're going to kind of stretch this out a little bit for x plus y, x minus y. Okay, so let's look at that. X and 2, that's going to be 2x. X and negative 3x, which is going to be negative 3x squared. Y and 2 plus 2y. Y and negative 3x, negative 3x y. Alright, and then we're going to have over here on this side the plus 3x squared plus 3xy. Now, when we put these together, there's going to be some cancellation here. You'll notice that the 3x and the 3x squared, those are going to simplify to 0. These are opposites. These are going to simplify to 0. And 2x and positive 2x and positive 2y just gives me 2x plus 2y all over x plus y and x minus y. You see anything else we can do? Yep, that's right. The numerator we can pull out a 2 and we get x plus y over x plus y times x minus y. X plus y simplify, so we have 2 over x minus y. We are done. Alright, finally problem number 13. Well, let's see here. I've got an x squared minus 1, which is the same as x plus 1, and x minus 1. It really is x minus 1 there. Now, you'll notice this is 1 minus x. Well, I can remove a negative here and make that a x minus 1. And this is already an x minus 1 here, but I'm going to distribute that to the 4 so I can make it a plus. So what I really need is I need an x plus 1 for these two right here. So my least common denominator is x plus 1, x minus 1, which also means my exclusionary values are x is not going to be equal to negative 1, and x is not going to be equal to 1. So let's go and take this second term here and multiply it by x plus 1 over x plus 1, and multiply this third term by x plus 1 over x plus 1. And what this will do, it'll give me the entire denominator of x plus 1, x minus 1. Now, 4x doesn't need any modification since its denominator is properly prepped. This negative 3 is multiplied by the x, which makes negative 3x squared. Negative 3 is multiplied by the 1, so this is negative 3x. Negative 4 is multiplied by x, so this is negative 4x. Negative 4 is multiplied by the 1, negative 4. Now it's time to simplify all this. So in my numerator now I've got negative 3x squared, and I've got 4x minus 4x, so those go away. And I have negative 3x here. And then I'm going to have my other part here, which is going to be, let's see, I'm going to take a negative 4 with that as well. So it looks like my entire numerator is opposite there. And then let's go with x plus 1, x minus 1. Now I can kind of hypothesize that this will probably not factor again, but it probably wouldn't hurt to check. So one thing I can do is I can factor out a negative 1 and make this 3x squared minus 3x plus 4. Multiply the 3 times the 4 and get 12, and I'm just doing a check right now to see if I can get anything to make a negative 3. My factors are 1 and 12, which doesn't make a negative 3. Let me think here. Wait a second. This should be a positive, and that should be a negative. All right, quick little change of pace here. 3 times 4 is negative 12, and I'm trying to make a 3. So 1 and 12 don't make a positive 3. 2 and 6 have no way of making a positive 3, even if I subtract one of them. And 3 and 4 don't make a positive 3. So I am pretty much done with this problem right there, because this, even if I tried my factoring, will not make a factorable problem using whole numbers. So that is the end of this worksheet. If you have any questions, please let me know.